So this is a cross-site scripting SSS game by the Google. This game is to give awareness for the users and developers to take serious about this attack. So in this game, we are going to try level 1 and introduction. So level 1, Hello World of XSS. So at first, this is a very common cause with the page without proper escaping. So we just need to do the action inside the window or inside the URL bar. So we just pop out a JavaScript alert. So this page function as in we search hi, and we found out that sorry, no result were found for hi. So how about we try header in HTML. We found out that it will output hi in a h1 header. So we found out that inside the target code, in line 38, there is a query, and then the 45 is exactly get the query and output it inside the web page. So this means that we can put the JavaScript directly inside the text field or in the URL bar. So I just copy and paste script alert, so it will pop out alert success. So for the level 1 will be done. Level 2, persistent is key. So it mentioned in the mission description where no matter where user control data comes from, it should be handled carefully, which is mean the customer can manipulate the data. So we put hi and we share the status and it will post hi. So it said that we just need to pop out an alert in the context of the application. So this is quite similar to level 1. It will post every time we put the script success, alert success. So it will put nothing and it doesn't have any alert pop out. So we know that we can put image in here. So we try put image source and it will output an image. So in the image tag, we can put one error to output the alert success. So at the end of it, we get it. So the site says that congratulations, you execute an alert. Level 3, that sinking feeling. So in the mission description, it describes JavaScript functions are execution sinks, which means that they will cause the browser to execute any scripts that appears in their input. So this fact is hidden by higher level APIs, which is used under this function. So our mission is still to inject a script to pop out a JavaScript alert. And it also mentioned that we need to manually edit the address in the URL bar. So if we look into the web page, if we click image 1, it will output image 1. Click image 2, we output image 2, and click image 3, we output image 3. So there is no text field. So we look into the coding. Okay, inside the index.html, level.py doesn't tell much. So index.html, there is var HTML look into the choose state. So it take the number and change the number into integer and directly put the number inside the HTML. And if we look closer, we will see that the HTML use the image tag and output it into the web page. This means that we can execute our payload or malicious script inside the URL bar using the one error. So we directly just put it inside the URL and we successfully pop out the alert.
Level 4. Contact matters. Mission: every bit of user supply data must be correctly escaped for the context of the page in which it will appear. Mission objective: inject a script to pop up a JavaScript alert in the application. The frame shows us the timer will do a counter based on the user input. The counting starts with 3 seconds and a pop-up to alert to the user. How about we do 6 seconds? We see that in the URL here, it shows that the timer inserted by user. So we look into the toggle code in the timer.html. Function starter timer is to get the seconds inserted by user. In the body section, we found that on load is assigned to timer in image tag. Go to label.file. In the line 17, it emits the value timer. We put our payload in it there. But take note that the URL needs to be read by the HTML. Thus, the attack is success. Level 5. Breaking protocol. Cross-site scripting isn't just about correctly escaping data. Sometimes attacker can do bad things even without injecting new elements into the DAUD. Mission objective: inject a script to pop up an alert in the content of the application. So we sign up first and enter email and next. So we see that after we click the next, it will go to the confirm page and back to the welcome page. In the coding, found out that the next can be manipulated and any value inserted in the next. It will redirect to that page, thus the attack is success. Level 6. Follow the rabbit. Complex web applications sometimes have the capability to dynamically load JavaScript libraries based on the value of their URL parameters or part of location, allowing user input to influence the URL when loading script or other potentially dangerous type of data. Mission objective: find a way to make the application request on an external file which will cause it to execute an alert. So in the frame we have no input next. So look into the toggle code. We found out that in include gadget function, the URL is not case sensitive, so we can insert HTTP or HTTP in a different lowercase and different uppercase for every alphabet, and it will load the URL given. This is part of require. In the URL, use data URL to execute the malicious JavaScript and success. So when the attack success, we click here and Ta-da! All the levels settled, and we got the cake.
Web application firewall. It can withstand internet attacks such as monitoring, filtering, or blocking data while traveling to and from web applications. Next, sanitizing. Helpful sites that allow HTML markup to ensure data received cannot harm to users, as well as the database by scrubbing the data clean potential harmful markup. Next, validating input. It prevents a user from ending special characters into a field, instead refusing the request. And lastly, escaping. To make sure that every part of a string is interpreted as a string primitive, not as a control character or code.